So till now we covered what is design, what are the design considerations, what are the various steps in the design process. On the course of it, we also touched upon what are the various concept selection techniques, right? And we also touched upon what are the various simulation techniques, say for example FEA, CFD simulation or DEM simulations for that matter, okay? Now an important aspect which the design engineer will come across day in day out in the work would also be the reverse engineering and the product tear down. Okay, so this can also be part of your concept selection, but I would like to place it slightly outside to it, mainly to give a focus for reverse engineering. So reverse engineering you basically use when you wanted to say benchmark a competitor product, or you wanted to basically understand the functionality of the competitor product. So you get the product, any product for that matter. You can also reverse engineer your own product, yeah. So get the product, break it down into components and try to understand the design information from the components. Okay, so reverse engineering, it's also called as back engineering. Okay, so reverse engineering as a product, it's nothing more than figuring out the design, yeah, from a product. Okay, so you don't go from a product to design, rather you come from you don't go from a design to product, but rather you go from product to design. Okay, so you have a product and you arrive at a design. Okay, in a normal product life cycle, you have design and then you have product. Okay, but in reverse engineering, you go from a product to design. Okay, and maybe an end product may also be a design drawings for that matter, or a CAD drawings for that matter. Okay, so basically the intention for you is to duplicate the product or to do some engineering and try to improve the functionality, so on and so forth. What is product tear down? So product tear down is a way to get details about the product design. So this will help the design engineers in terms of getting more information about the product. Yeah, I think reverse engineering and product tear down is also kind of hand in hand. Okay, it's very close, but mostly the reverse engineering at the end you have the design, but in a product tear down you go only up to certain level and you try to understand the functionality of each and every component. Okay, so product tear down is very common. As a design engineer, you would try to break down the product and try to understand it. Say for example, you join an automotive company, yeah, you may have the engine, yeah. So as a fresher or as any associate for that matter, right, you wouldn't be you would not understand the functionality of each and every component into it directly, yeah. So they may also have this tear down component, or they may also have a cut section, and they may also have the components which is placed apart. You can actually have a view of the component and try to understand what functionality is associated with what component, so on and so forth. So it basically improves your understanding of the product. Okay, so this reverse engineering and product tear down is one of the important aspect which design engineer like you would come across in your day-to-day working environment. Let's take an example of product tear down. Yeah, certainly the texts are pretty small, but the intention is not to get into the details of the text. Yeah, say for example, we take an example of a automotive suspension or a bike suspension, whatever for that matter. Okay, this is the complete design this is the complete assembly what we have. Okay, now the product tear down of this would be various components what's available inside the assembly. Okay, so on the image here you see what are the various components, or what are the various part inside this assembly. So one is the spring, yeah, so this is the spring. this is the entire component, this is the entire assembly, and this assembly or a system will have different components. Spring is one component, damper is a component, okay, spring, and then you have a damper which is this one, and then you have sleeve, okay, and then you have a holder, so this part is called as the holder, okay. So you basically break down the entire product, or you tear down the entire product, and you write what are these products are. Yeah, say you have holder bush, you have tension adjusting metal bush which you can rotate, you have sleeve ring, you have bush, you have rivets, you have nuts, so on and so forth. Okay, now what we do is, you have basically the assembly. So here there is a part name, there is quantity, and what is the function of each and every component. This is something which we have to write down, okay. And what is the manufacturing process to manufacture that particular component, okay. So in a product tear down for automotive suspension, what I have done is I have taken the broken down this entire system or the entire assembly into different subcomponents, okay. Basically I have removed the entire suspension myself, and I have put one part, say for example spring, and I am writing down what is the function of a spring. Spring is to rebounce or store the mechanical energy. So that's the function of the spring in an automotive suspension, is to store the mechanical energy, okay. Now damper, the function of a damper is to dampen the mechanical vibrations basically, okay. So the manufacturing of a damper would be by drilling the cylindrical component, and by turning and drilling basically, okay. And then what is the manufacturing process for the spring? So spring you can actually purchase, or a spring manufacturer would be thinking about various spring operations as such, okay. So we are writing down what are the part, okay. So basically we are writing down what are the part and what are the quantity, how many pieces we have inside the system, and what is the function of each and every component, and what is the manufacturing process, okay. And at the end we can have the dimensions. So what are the dimensions? Say for example, if it is spring, I am mentioning that what are the number of windings, okay, what is the pitch, okay, what is the pitch for the intermediate coil, okay. So what is the major coil diameter, what is the wire diameter, okay, so on and so forth. I write down what are the mechanical dimensions of the spring for this component for that matter, okay. And then coming to damper, what is the dimension, what is the external dimension of the damper, what is the external diameter of the damper, what is the internal diameter of the damper, okay. And inside damper you will also have a piston. So basically if you see there is a damper, then you will have a piston arrangement inside it, okay. And there is going to be fluid here, all right. So what is the diameter of the piston? So all these things are going to be mentioned here. I'm going to remove it, or I've already removed it and mentioned the measure the diameter. For that matter, then you can use a vernier caliper or a screw gauge according to the size of your component, and you can measure it, okay. So sleeve, similarly holdings, so on and so forth. So this is a product tear down through which I would get to know what is the mechanical dimensions of each and every product, and what is the function of the product. Yeah, so now we know much better than just seeing the suspension, right? What is the functionality of the each and every component inside it. For that matter, even nut, I don't know if you'll be able to see, okay, but the function of the nut is to prevent the movement of the piston shaft further after the extreme position in the suspension, okay. Rivets provide the constraints for spring at one end, help the tension for changing, help in changing the tension of the spring, okay. So there is rubber bush, separates the piston rod to the nut. So this rubber bush separates the piston rod to the nut. So these are various functionalities. Yeah, now we know that by this product tear down, okay, we understand each and every function. Okay, for example, you can also think about combining two components, so on and so forth. That could be an innovative, approach. Yeah, but rather I would stop at explaining you that in a product teardown, basically we take any assembly and you break down the products and you break down the product into different components and you try to have a functionality or a rationale behind the availability of each and every component for that matter. Yeah. So now once I have the product tear down, the next step what I'm going to do is I'm going to put it into a STM or the spring testing machine. Okay, it's a helical spring, linear helical spring. I'm going to put it under a spring testing machine. Okay, and then so this is a measurement phase. So this is just a practical example of you have a component, you tear down and then you measure it. Okay, and you get the characteristics. Okay, now in a spring testing machine, I'm going to keep increasing the load. Say for example here from 0 Newton to 300 Newton I've increased the load, and I'm going to study or measure what is the deflection in the spring. So for this amount of load, what is the deflection? So my spring testing machine will be able to give this detail. Okay, I'll be able to apply load at various intervals and I'll also be able to get the deflection. Okay, simple. So I have a table of load versus deflection. Okay, this load Newton versus deflection, it is your spring constant, or it's called as stiffness. The unit of stiffness is Newton per meter. Okay, Newton is on y-axis, meter is on x-axis. Okay, so this spring this load deflection, the slope of the load and deflection chart will give you the spring constant, which is a metal property. Okay, now just if I buy a suspension, I would not know what is the stiffness of the spring, because this is one of the important characteristics of the suspension. Yeah, because it's going to provide that cushioning. Okay, now because I performed this testing, now I got the spring constant. Okay, say for example whatever I showed in the previous slide, that is the load and deflection table, I've just plotted it, and the slope of it would give me a spring constant. Okay, so I think all these texts are not very important, but the critical thing here is to understand that you break down the product and you do the testing and get the product constants, functionality, so on and so forth. Okay, okay, all right. The other thing in the design process is the customer needs. Again, I'm also covering it separately here, because you have customer need, okay, which has to be converted into a technical requirements. Okay, so in a customer need, the customer would just give you can just go to a customer with a survey or with an interview questions, wherein you're going to get the information from the customer in terms of what is the requirement, what he or she is looking at. Okay.